Okay guys, in this section 6-5 we're looking at the properties for a rhombus. Alright, and the first thing that we want to note is that a rhombus is a parallelogram. So all four of the properties for a parallelogram a rhombus also has. In addition to that, it's got three of its own properties, and here's what they are. Number one, it's got four congruent sides. So all four sides of a rhombus must be the same length. Okay, number two, the diagonals are perpendicular. So when the diagonals cross each other, they hit at 90 degrees. They form a 90-degree angle in the center there. The diagonals are perpendicular. And of course, if one of these angles is 90 degrees, all of them would be 90. And then the third property, the diagonals are angle bisectors. That means the diagonals split the angle in half. So if this angle is 30, the other one would be 30. Or if the entire corner right here angle is 60, it'd be split in half to 30 and 30. All right. Now, here's some of the other properties for being a parallelogram. The opposite sides are congruent. Well, remember, if all four sides are the same, then the opposite sides are the same. Remember, the opposite angles are congruent. And so really what that means, if this is 30 and 30, then the opposite angle gets split in half to 30 and 30 as well. Same thing here. If this is 60 and 60, this would be 60 and 60 as well. And some of the other properties, opposite angles are congruent, consecutive angles are supplementary. So if you add these two together, you get 60. These two together, you get 120. They add up to 180. And then, of course, the diagonals bisect each other. They cut each other in half. So all of those are the properties for being a parallelogram. And then, like I said, in addition, you get these three as well for a rhombus. Okay, so just like in some of the previous sections, we're going to be using these properties to answer some of the questions. Okay, so like here's the first problem that we want to look at. So again, it tells us that the figure is a rhombus. And remember, that part is important. We have to know that the figure is a rhombus before we can use the properties. All right, so if we don't know that that figure is a rhombus, we don't know if these properties apply or not. So that's important to either get from the directions that it's a rhombus, or if they mark all four sides the same length, then we know it's a rhombus and that sort of thing. Okay? All right, so what are they giving us in this first problem? It says DE is 5, and then find the length of segment DB. So DB is the full diagonal. DE is half of the diagonal. Remember, for being a parallelogram, the diagonals cut each other in half. So if halfway is 5, then DB, the whole segment, would have to be 10. All right, so we can just look at that one and figure out the right answer. Didn't really have to do any work for that one. What about the next one, though? Let's say that BC is 25. They give us that. So we'll go ahead and mark it on our drawing. BD is 40. Now BD is this full diagonal. So instead of writing a 40, remember the diagonals get cut in half. So I'm going to put 20 on this side, 20 on that side, and then altogether the 20 plus the 20. That'll give us the 40. All right, so what are we looking for? We are looking for CE. So this segment is the one that we're actually looking for right here. Okay, now here's the deal. Remember, in a rhombus, the diagonals are perpendicular. So that means these angles in the middle of the figure are going to be 90 degrees, the angles formed by the diagonals. So what we've got here is we've got four right triangles. So if I just look at this one, then notice I have two sides and one missing side. So if you think back to algebra, in a right triangle, if you have two sides, then how do you find the missing side? Well, remember, in a right triangle, you can use the Pythagorean theorem. A squared plus b squared equals to c squared. And that's what we will use here. Remember, with the Pythagorean theorem, you just got to make sure that the hypotenuse goes for c, right? So we'll say that this is an x, this is 20, and then the hypotenuse is 25. So when I plug in, it'll look like this. X squared plus 20 squared equals to 25 squared. So remember, the hypotenuse, the side that's across from the 90, always has to be your C. The hypotenuse is always your C. Alright, so how do we finish it? It'll be x squared. I can go ahead and square 20 and get 400. I can go ahead and square 25 and get 625. Now to finish solving it, I'll move the 400 to the other side. We'll get x squared is equal to 625 minus 400. Whenever it goes across, it's got to change signs. So now we're left with x squared is equal to, when I subtract that, that's 225. Okay, so now remember, if I have x squared equals to 225 and I'm trying to figure out the value of x, to get from x squared to x, I need to take the opposite of squared, which is square root. Take square root of both sides. Square root of x squared is x. Square root of 225, that's going to leave me with 15. And so that would be the length of CE, and then there's your answer. Okay, so some of these problems will have to incorporate the Pythagorean theorem, a squared plus b squared equals c squared. Remember, your c has to be the hypotenuse. The other two are really interchangeable, but make sure that your hypotenuse goes in for c. How do you know which side is the hypotenuse? It's the one that's across from the 90. The two that are connected to the 90, those are your legs. That can't be your c. The hypotenuse, the one across, that's going to be your c. All right. Okay, so here's another type of problem here. Again, it's telling us that the figure is a rhombus, so we know we can use the properties. Okay, so they're giving us the measure of angle DCA, and based on that, we have to find three other angles. So let's locate the angle that they've given us first. So remember, you've got to make sure that you remember from Unit 1 how to identify angles. Angle DCA, where is it? DCA. That would be this angle. That's 62. Remember, the middle letter is the vertex. Keep that in mind. And you trace it out, there's your angle. Now, here's the deal. Okay? Because of the properties in a rhombus, if they give me one of these angles, I can actually get all of the angles around the rhombus. Okay, and here's why. Remember, we said that the angles, the diagonals are angle bisectors, so if this is 62, this has got to be 62. The diagonals cut each other in half, right? And here's the other thing. Remember, the opposite angles are congruent. So if this is 62 and 62, then this one's got to be 62 and 62. Now, I can get these other angles here. Okay, now I realize they're not asking me to get all these angles, but if I go ahead and fill it in, I'll have all my answers. Okay, now look at this triangle. You got 62, 90, and a blank angle. Well, remember from a couple of units ago, all three angles on the inside of a triangle add up to 180. So if I do 180 minus 90 minus 62, that leaves this angle to be 28. And so if this is 28, the other half is 28. Remember, the diagonals are angle bisectors, and the opposite angles are congruent. So if I got 28 and 28 here, then I've got 28 and 28 here. All right? And so now let's just look and see what angles they're asking me for. There were three of them. The first one, BAC. Let's find that. Angle BAC is 62. Angle ADB. ADB is 28. And then the last one, angle AEB. All right, let's find that. AEB is already marked for us. It's 90 degrees, and a matter of fact, any one of these four in the center would be 90 degrees. Why? Because the diagonals are perpendicular. All right, so there you go.